Welcome to Chemistry at Honeyniga High School. I'm Brian Brown, and today we'll be looking at our second installments of dimensional analysis where we look at multi-step problems. Yesterday, the types of problems we studied, when you had a given and you were going to some target unit, you could always do it in one step. One conversion factor would get you from point A to point B. But there'll be cases where you don't really know how many of a certain unit is equivalent to our target unit. So you can't do it in one step. You have to do it in multiple steps. So that's our multi-step problems. Now, in a multi-step problem, you need to understand that sometimes one conversion factor just won't get the job done. So if we don't know an equality between our given and our target unit, we'll have to do the problem in more than one step. Everything we looked at in the first set of notes, if you knew how many centimeters we wanted to get to meters, you know there's 100 centimeters in a meter. If you had 48 seconds and you want to know how many minutes that was, you know how many seconds are in a minute. But in all cases, you won't know between your given and your target the numbers that would make them equivalent. A good example of this is when we have a metric prefix unit and we're asked to change into a different metric prefix unit. Whenever we have that type of situation, we're always going to have multiple steps. So in the case of how many decimeters are in 425 kilometers, well, I know I want to get rid of kilometers, but if I think about what I know about kilometers, the only thing we studied was the fact that there's 1,000 meters in a kilometer, and that's it. We didn't have any equality between kilometers and decimeters. So that means we're going to have to do it in multiple steps. Now, if you take a look at the equalities we had in metric, you can see then that in every case, we changed the prefix unit into a base unit. We went from kilometers to meters, hectometers to meters, decameters to meters, decimeters to meters, and so on. So the only thing we really know how to do with a metric prefix unit is change it into whatever the base unit is. And don't forget, these are interchangeable qualities. So if we wanted to change between kilograms and grams, the same exact thing applies. So the only thing we can really do with the prefix unit is change it into some base unit. Now, one of the things you need to remember, because you won't always be seeing these equalities in problems because you're expected to know them. From first semester, we said you should know what kilo, deci, centi, and milli means. So that means these are all fair game in a question for me not to give you the equality. Other types of metric conversions, I wouldn't expect you to memorize them. So if there was hectometer in a problem or hectogram in a problem, I would always tell you the equality between the hecto unit and the base unit. But those are the ones you have to have memorized. So these you don't have to be told what they are. Now, remember, metric prefixes are interchangeable with any base unit. So if 1,000 millimeters equal a meter, then remember 1,000 milligrams also equal a gram. So don't let a different base unit throw you. It would also be true that 1,000 milliseconds equal 1 second, or I guess technically 1,000 millipencils equal one pencil. So you can use prefixes with any base unit, and they're interchangeable. And that works with anything, as I said, meters, liters, grams, seconds, all of them. Now, one of the fundamental things you need to understand is that you can then change any prefix unit into a base unit in one step. So all prefixes are defined as equal to the base unit. So in one step, you can always go from a prefix unit to the base. So if you see in a question, they give you a base unit and a prefix unit, you're one step away from answering the question, regardless of which direction you're going. Because that's what we know about prefix units is how many are equivalent to the base unit. The other thing you need to understand here is you can change any base unit into a prefix unit. And that's why I said you can go either direction. So if we have any base unit, we can go to any prefix unit in one step. So what that means is if we have a prefix unit going to a prefix unit, it's always going to take 2 steps. So when you read the question, if you see 2 prefix units, the number of prefix units is going to tell you how many steps or how many conversion factors it's going to take. And along the same lines then, if you see only one prefix unit because the other one is a base, you know it's only going to take 1 step. So the number of prefixed units you see in the problem is going to tell you how many steps a metric conversion problem will take. And we spend quite a bit of time here talking about metric conversions and making this connection because one of the most common applications of dimensional analysis is for metric conversion. So you need to understand and be fluent with it because you're going to see a number of these in the test. So all prefixes are defined as equal to the base unit. So therefore, when you change a prefix unit, you're always going to be changing to the base unit. And then to get a different prefix, you're going to have to go from that base to another prefix, 2 steps. So, case in point, a pencil is 17.8 centimeters long. What is the length in kilometers? Now remember the process when we set these questions up. We first put our target. The question is asking for how many kilometers. Next, we want our given. Now, often the given is right where the question is, but in this case, it was in a separate sentence. It said the pencil was that many centimeters long. So that is our given. And then we work the process. Exact same thing we did with single step, but now we're not going to get there in one sequence. So step 4, do I want to keep it? No, I don't want centimeters, I want kilometers. So that means get rid of it. And you get rid of something on top by putting it on the bottom. Step 5, what can I change it into? That means what do I know it equals? Well, every prefix unit, all I can do with it is change it to the base. That's it. And then step 6, actually, to finish step 5, I should say, we need to add the numbers to make them equal. And here you're really just copying. I know there's 100 centimeters in a meter, so I've got to put the 100 by the centimeter and the 1 by the meter. And I have successfully gotten rid of centimeters, and now I'm in units of meters. But step 6 was, do I want to keep it? Well, the answer here is no, I don't want to keep meters. I want kilometers, so I have to keep going. So I need another step. So draw another line. And now I continue on. Do I want to keep meters? Nope. So put it on the bottom. What can I change meters into? Well, remember, any base unit can be changed to any prefix. So I can go to kilometer because I can go to any prefix unit. And just like centa, you were supposed to have memorized what kilo stands for. So this is one you won't be given it often in the problem. You'll need to know. Kilo means 1,000. So in 1,000 meters, you have 1 kilometer. And at this point, every unit is canceled except for the target unit kilometers. So this must be my correct solution. 17.8 divided by 100 divided by 1,000 will give me my correct answer, 0.000178 kilometers. Now, mention about sig figs, we're starting with 3. In this case, everything in between is a defined quantity, so those are all unlimited. So I start with 3, I got to end up with 3. So 0.000178 kilometers. Now, there's other types of multi-step problems besides metric conversions. But metric conversions are going to be common because it's one of the things we apply dimensional analysis to. So let's look at a different situation that you should also be familiar with. How many seconds are in 2.5 weeks? And this is something some of you might be able to get out your calculator and maybe figure out, but I bet a ton of you would make simple math errors along the way. If we set up our dimensional analysis setup, you shouldn't make any math errors because it'll be right in front of you exactly what you need to do. We're trying to get to seconds. They tell us we've got 2.5 weeks, so that's our starting point. So work the process. Do I want to keep it? No. So I need to get rid of weeks. I'm going to put it on the bottom. What do I know about weeks? Well, I know how many weeks are, let's see, I don't know seconds. I don't know minutes. I do know that there's 7 days in a week. So I can go from weeks to days. Now, all I need to do, remember to finish step 5, is add the numbers that make them equal. And then I said 7 days in 1 week. So we're going to put 1 by the week, 7 by the days. But we're not done in step 6. Do I want to keep it? No, I don't want days. Now I'm closer. I've gone from a larger unit to a slightly smaller unit, but I'm still not to second. So I've got to keep going. So next, I need to get rid of days. Well, what else do I know about days? Well, I know there's 24 hours in a single day. So I know an equality between hours and days. So 1 day, 24 hours, but I'm still not done. Do I want to keep it? No. So now I need to get rid of hours. What can I change hours into? Well, I know how many minutes are in an hour. There's 60 of them. So now I can plug in those numbers. Do I want to keep minutes? No. So I keep going. Minutes have to go on the bottom to get rid of it, but I do finally know how many minutes equal how many seconds. So I can put seconds on top. I know for every 1 minute, I've got 60 seconds. So 1 by the minute, 60 by the seconds. And at this point, every unit cancels but seconds. All of my conversion factors are valid equalities, so this has to be the setup to the problem. 2.5 times 7 times 24 times 60 times 60. That should give me how many seconds. Now, before we move on, brief word about final answers here. Lengths of time are not counting things. So when I say 2.5 weeks, that has to be a measured quantity, and that has limited significance as a measured quantity. 2.5 weeks would have 2 sig figs. If I wanted 2.5 weeks with 3 sig figs, I'd have to write it as 2.50. Now, in between, every one of my conversion factors here is a defined exact quantity. So if I started with 2, I need to end up with 2. So how would I write 1,512,000 to 2 sig figs? Well, I'd have to round it at the 5. And since the next digit was a 1, that would become a 0. And I could write it as 1,500,000 seconds. And now this would be my best answer to correct significant digits. Now, since we're getting a large answer, there's no reason why we couldn't put this in scientific notation. 1.5 times 10 to the 6th seconds means the exact same thing and also still has two sig figs. So we could write it in that form if we wanted to. And that's how you handle multi-step problems. If you're if you don't know an equality between your given and your target, then you're going to have to do multiple calculations, multiple steps to get there. Now, the last one I wanted to look at was to kind of work in the other direction, just to practice some math here. How many years are in 1.35 times 10 to the 7th seconds? So now I'm trying to get to years, and I'm starting in seconds. Oops, I got to back up here. And this one I'm going to have to write out by hand. So if I have 1.35 times 10 to the 7th seconds, I'm going to leave myself a lot of workspace here. And I know I'm trying to get to years. That's my target. So I'm getting to years. I've got that many seconds. So let's work the process. I don't want seconds. What do I know about seconds? Well, we just talked about the fact that I know that in 1 minute we have 60 seconds. So seconds are gone. I'm now in minutes. Don't want minutes. What can I change a minute into? Well, I can change them into hours. I know there's 24. No, I don't. It's not 24 hours equals 1 minute. Remember, the numbers I put in, the two things have to be equal. And clearly I started to write something that wasn't. So that must mean I need to rethink. Well, how many minutes are in how many hours? Oh, it's 1 hour is 60 minutes. Now that's a valid equality. That's a valid conversion factor. So I've gotten rid of minutes, and now I'm in hours. Well, I don't want hours. I want years. So what do I know about hours? Well, I know how many hours are in 1 day. So I can go to days. 1 day is 24 hours. And now finally, I don't want days. I'm still trying to get to years, but I do know in a typical year, there are in 1 year 365 days. So at this point, every single unit has canceled except for years, and it's on top like it's supposed to be. And every single conversion factor, because I caught myself when I started to make a mistake there, every single conversion factor is equivalent to 1. They're all equal to each other. So that means this must be a valid solution. So now you get out your calculator. And remember what this means mathematically. You've got 1.35 times 10 to the 7th on top. And on the bottom, you're going to have 60 and 60 and 24 and 365. Now, some people will plug in the 1.35 times 10 to the 7th. And remember, don't hit times 10. That's your EE key typically on your calculator. So you'd enter 1.35, and I'm doing that right now. So 1.35, hit my EE key, and then to the 7th. And now I'm going to divide by 60. Now, some people look at that and say, oh, then I multiply by another 60, multiply by a 24, multiply by 365. Well, my calculator needs to be addressed in a very specific way to mathematically get the right answer. So technically that 60 that's on the bottom, yes, I would be multiplying it by 60, but I'm actually dividing it into the number on top. So if I just hit times 60 times 24 times 365, I've got to make sure I put everything in parentheses so that it's multiplying everything together on the bottom and dividing it all as a group into the number on top. Well, I don't really need to make it that complicated. Just hit times everything on top and divide everything on bottom, and it does the same thing. So I divide by 60, then I divide by 60 again, then I divide by 24, and then I divide by 365. And at that point, I see that I get, and once again, I got to think sig figs here. I started with 3 sig figs, so I'm going to end with 3. I get 0.4280, so I'm going to round that to 4 or 0.428 years. So that would be a little bit less than a half a year. So that would be how you handle multi-step problems. And remember, in multi-step problems, you're going to have a bunch of things on top and a bunch of things on bottom. Easy way to do it is hit times by everything on top and divide by everything on bottom, and you will get the right answer. Otherwise, you have to very carefully use parentheses, and too many students will make mistakes when they're trying to do that. Plus, it's more work. So keep it simple. And that ends our set of notes on multi-step problems.